Today we're going to be solving polynomial equations in factored form. As always, your standards are provided. Please look over those. And to be successful, you need to be able to use the zero product property to solve polynomial equations in factored form. You need to be able to factor polynomials using the greatest common factor, and you need to be able to solve polynomial equations by rewriting them in factored form. So, what do you call a starving parrot? A polynomial. A poly, no more. I know, it's kind of corny, but got to get started with something funny. All right, so some vocabulary that you need to be familiar with. A polynomial is in factored form when it's written as a product of factors. Here's some examples. So standard form, remember, is from your highest exponent down. So your standard form comes from your degree, which is your exponent, and this is a second degree polynomial, second degree binomial to be more specific. And in factored form, it would be x times x plus 2. So you can see that x times x is x squared and x times 2 is 2x. Factored form is just another way to write it from standard form. All right, here we have x squared plus 5x minus 24. That can be rewritten as x minus 3 times x plus 8. Again, if you do x times x, you get x squared plus 8x minus 3x is plus 5x in the middle, and negative 3 times 8 is negative 24. So even though standard form and factored form look very different, these two expressions are equivalent. They're just written in different forms. All right, the zero product property, if the product of two real numbers is 0, then at least one of the numbers is 0. If a and b are real numbers and a times b is 0, then a equals b or b equals 0. Roots are the solutions of the equation. Repeated roots is when two or more roots of an equation are the same number. The equation will then have repeated roots. All right, key idea, zero product property is something we're going to be using. All right, if the product of two real numbers is 0, then at least one of those numbers is 0. Algebraically, if a and b are real numbers and a times b is 0, then a equals b or b equals 0. Again, we're going to be using this to solve polynomial equations today. Example 1, solving polynomial equations. All right, so this is in factored form. I have 2x times x minus 4 equals 0, and it says to solve. So I've got a times b equals 0. Remember, zero product property says a can equal 0 or b can equal 0, and you can solve. So this is very easy. We just have to put 2x equal to 0, and we have to put x minus 4 equal to 0, and then that will give us a way to solve. So divide by 2. We're always solving for the variable. 0 divided by anything is 0. And then I'm going to add 4 to both sides for this one. X equals 4. So x equals 0 or x equals 4. That would be my two solutions for A. You can also plug those in to check it. All right, for B part, x minus 3 times x minus 9 equals 0. This is, again, in factored form. We can say x minus 3 is the same as A. X minus 9 is the same as B. So we can set each one of those equal to 0 and solve. So quick and easy, x equals 3. Add 9 to both sides, or x equals 9. Again, that's our two solutions here. All right, C part, we have 2x plus 7 and 2x minus 7 equals 0. So we're going to have 2x plus 7 equals 0. And we're going to have 2x minus 7 equals 0. Again, we're just calling the first factor A and the second factor B. Since we have A times B equals 0, we can set each factor equal to 0 and solve. That's the zero product property in a nutshell. All right, so we have 2x equals negative 7. Divide by 2. This one has a couple steps. So negative 7 halves. That's the same as negative 3.5, but if you want to leave it as a fraction, that's fine. So here I'm going to add 7 to x equals 7 divided by 2, x equals 7/2. So I've got negative 7/2 or 7/2. All right, so to solve an equation, use the zero product property, set each factor equal to 0, and solve. I do want you to try this. Pause the video, do the self-assessment, and then come back to check your answers. All right, hopefully you took a little time to do these on your own. If you set 3t equal to 0, divided both sides by 3, you would have got t equals 0. Then you should have set t plus 2 equal to 0, subtract 2 from both sides, and you would have got t equals negative 2. For B part, you got z minus 4 and z minus 6 equals 0. Set each one equal to 0 and solve. So the first term you would add 4 to get z equals 4. The second one you would add 6 to get z equals 6. For C part, you should have got z equals 4/3 and z equals negative 4/3. You would have added 4 and then divided by 3 in order to get that. If you're not sure how to use the zero product property still, please reach out and I will be happy to assist you. Solving polynomial equations, example 2. All right, so this one says x minus 1 quantity squared equals 0. So if you remember, when you've got a binomial squared, that's the same as x minus 1 times x minus 1 equals 0. Because when you have something squared, that means you multiply it by itself. So that's why we have x minus 1 times x minus 1. So then to set this up, we're going to have x minus 1 equals 0, x minus 1 equals 0, and then solve. And as you can see, you're going to get x equals 1 or x equals 1, which means the equation has a repeated root at x equals 1. All right, B part, you've got x plus 1, x minus 3, and x plus 1 equals 0. So again, you can use the zero product property. Even though there are 3 binomials here, you still do the exact same thing. X plus 1 equals 0, x minus 3 equals 0, and x plus 1 equals 0. Subtract 1, x equals negative 1, add 3, x equals 3, and then subtract 1, x equals negative 1. So for B part, this one has 2 solutions, x equals negative 1 and x equals 3, where x equals negative 1 has a repeated root. So the study tip, you can extend the zero product property to products of more than 2 real roots. So if you have a binomial squared, you can expand that. If you have 3 binomials, 4 binomials, or even more, the zero product property will work for those. It does extend through more terms as well. All right, example 3, factoring a polynomial using the GCF. GCF is your greatest common factor. So it says factor out the greatest common factor from 4x to the 4th plus 24x third. All right, so first just look at the numbers. You can tell both 4 and 24 have a GCF of 4. So we know that we can pull out a 4, but we also have to look at the variables. So if you look at x to the 4th and x to the 3rd, you can see that your greatest common factor there would be x to the 3rd. You can pull 3 x's out of 4, but you cannot pull 4 out of 3. So 4x to the 3rd would be my greatest common factor. I would have 1 left here, and I would have 1x left here, and I would have 6 left here. So if I wanted to write this completely, all right, so this, whatever this is, should equal what you have down here. So I pulled out my greatest common factor. So 4x to the 3rd, again, if I pull that out of my first term, I have 1x left. And then if I look at my second term, 4 goes into 24 6 times. And then the x to the third is already been pulled out. So you can use distributive property to check to see that factored form n does represent the same thing as standard form. It's just written in a different form. All right, I want you to take a few moments and look at the self-assessment. This is the perfect way to see if you're understanding what we're talking about. So do the self-assessment, solve the equation, and check your solutions. There's A, B, and C part here. Should be quick and easy. D part says different words, same question. Which one is different? So evaluate these 4 and see which one is different. And then factor the polynomial. Okay, look for a greatest common factor and then completely factor it from there. So this may take just a few moments. That's fine. Pause the video, work on these, and then come back when you're ready to check them. All right, let's see how you did. So A part, 3s plus 5 times 3s plus 5 equals 0. Your answer is s equals negative 5/3, and that does have a repeated root. All right, we have b plus 7 quantity squared equals 0, so b equals negative 7. Again, this one has a repeated root. Remember, a root is the solution to the equation. All right, C part, if you set each factor equal to 0 and solve, you get d equals 2, d equals negative 6, and d equals negative 8. D part, different words, same question. Which one is different? All right, it says find both answers. This one says solve the equation, 2k plus 4 times k minus 3 equals 0. Find the values of k for which 2k plus 4 equals 0 or k minus 3 equals 0. Okay, so this one's set up using the zero product property, but it's the same as this. And this one says find the roots of the equation. The roots is find a solution, right? Just another word for solution. Find the roots of the equation, 2k plus 4 times k minus 3 equals 0. Again, is the same question. All right, this one says find the value of k for which 2k plus 4 plus k minus 3 equals 0. So you know that the others are multiplication. This one is addition. So this one's going to actually have a different answer. If you add two binomials together, you have 2k plus k is 3k, 4 and negative 3 is plus 1. So to get the answer for this one, you would have 3k plus 1 equals 0. So you would subtract 1. 3k equals negative 1, divide by 3. K is going to equal negative 1/3. All right, so you know that for all the others, you're going to have, this would be negative 4 over 2, which reduces to negative 2. And this one would be add 3, which k would just equal 3. This one would give you the same answer as this. This one would give you the same answer as that. So for 3 of these, we're going to have k equals 2 and k equals 3. That's going to be negative 2. Sorry, you subtract 4 and divide by 2. Subtract 4, divide by 2, you get negative 2. All right, so that's going to be the same answer for the first, the second, and the fourth one. But the third one is only going to have one answer of k equals negative 1/3. So hopefully you can see the difference there for that third one. That plus makes a big difference in what your answer is going to be. All right, hopefully you did well. Please join me for the rest of this lesson in the next video.